Okay, let us now cases of climbing ladders. So we are going to start with a simple one as we progress to more simple ones. Okay, and from ladder AB rests to its upper end A against a rough vertical wall. Remember you hear the word rough, it means that we expect friction somewhere. And B on a rough horizontal, rough friction somewhere. With the coefficient of friction at A, 2/5 and a half respectively at B. If the angle between the ladder and the floor is 45 degrees, find how far a man of weight a half of the ladder ascends before it slips if the height of the ladder is 8. If the length of the ladder is 8 meters. So what we do, we start by doing a simple diagram to illustrate everything there. So we have, this is going to be our vertical wall. We have a horizontal flow. Okay, my ladder is going to be from there up to here. From there up to here. Okay, with the part which is resting with on our vertical wall is A. Then this one on the floor is B. You start asking yourself, do we have contact between the ladder and the floor? Yes. We have this. We have this. If there is contact, we expect a reaction which is perpendicular to that. So we have reaction at B. When here there is contact, so we have reaction at A. You go slowly. Because this is vertical, this is horizontal, they are perpendicular to each other. What else do we have there? Now here, they are telling us that, we have this is the uniform ladder. The uniform ladder means that the weight is acting in the middle of that ladder. Were we given the weight? No. That's why we say, let W be the weight of the ladder. So I press the middle. For me, my middle is going to be here. So I say this is going to be my middle part. So and the weight is acting there as W. Now this is weight. If it was mass, multiply by 3. If they give you weight, you don't need to multiply. That's why I'm having that there. So because this from here up here is 8 meters, the length, it means this one is in the middle. So from here, it's going to be 4 meters. And also here, it's going to be 4 meters. From here up to here, then from here up to here. Okay. The floors, the floor and the wall were rough. What comes into your mind with expect friction? So this one is about sliding. So when it slides, it's going to go like this. So the motion is going to be that side, so friction is going to be this side because it's going to be opposing. So you're going to be having friction there. So friction at B, remember our friction is given by mu R, where R is the reaction. So the friction at this B is going to be mu. They gave us the coefficient of friction. This is the coefficient of friction. There, it is at B is a half, so this is going to be a half. The reaction is R at B. Then here, because this when it slides, this one is going to be like this. It's going to be in this direction. So our frictional force is going to act upwards. So our frictional force at A is mu 2/5. Then R A. That's what we have there. Okay. We are almost there. What are we missing? They gave us this angle as 45 degrees. Okay. Now we are saying let Y be the length the man ascends before the ladder slips. So let me call this Y. Let me say from here up here is going to be my Y. This man is going to ascend up there, distance Y, before the ladder slips. So let me say up to here. This is going to be Y. From there up there, let it be Y. It means that now the weight of this man is going to act here. But you told us that the weight of this man is a half the weight of this ladder. So it's going to act here, but it's going to be a half of the weight of the ladder. Of course, if the weight is bigger, it's most likely to break. That's why the weight is a half of that of the ladder, so that it cannot break with ease. Even this one you can bring, but at least if the weight is a half, then it can. Okay. Now that's the diagram. We have everything is there. Now means that now after getting there, we start by resolving. How are we going to start? We start horizontally. We can start with the vertical resolving, no problem. So resolving horizontally, because it's about solution, it's in limiting equilibrium, and there friction is at this maximum. So going in that direction, we have RA equaling to half. This is the opposite RB. So it's when I multiply here, my RB is going to be giving me 2RA with ease when I have that. So I call this equation 1. Then I resolve vertically. When I resolve vertically, what do we have? We have RB plus. These people forget this, but don't be one of them. RA is equaling to, this one's acting downwards, W over 2, then plus W. But we have RB in terms of that. This is going to be 2 RA plus 2 over 5 RA equaling to, add there again 3 over 2 W. So to simplify here, this is going to be 10 plus 2, that is 12 RA over 5 equaling to 3 over 2 W. By 3 once, by 3, 4. So imply that from here, our RA is going to be this. It's going to go there, 5 over 8. This 4 that comes there. W. I call this equation 2. Okay. When you have that now, the question is how are you going to involve our y into the systems? You start by the order is to take moments. Now I have here this, and it's where this thing we are going to take moments from. It's easier to take moments at the y. I can easily get a perpendicular distance from B to these forces than getting a perpendicular distance from A to these forces here. You can, but it's going to be a bit lengthy. So that's why I'm taking always my moments at B. So taking moments at B, this shows I'm taking them anti-clockwise. Okay, so we come to B here. This force you see, anti-clockwise. Even this one, anti-clockwise. Now to B, we have this force clockwise. Even this one to B, clockwise. Okay, now we start with this one or this one here. Over half W. So our half W times, remember our moment is given by the force times the perpendicular distance. Now, what's the meaning of perpendicular distance from B to this one? Now there is a very simple diagram. This one is what we are going to use to get that distance. Now, this angle here is 45. But now, from here up to this weight, the distance is y. Can I get this? Yes. I want, because this force is vertical, it means that the perpendicular distance has to be horizontal. So meaning this is going to be y, then because it's adjacent, cos 45. So now I have the perpendicular distance, so meaning from here up this force is going to be y cos 45. Then plus W, this one. How am I need now the perpendicular distance from here up here. I draw another triangle. This is how you get those perpendicular distances with ease. So this one is going to be 45. Now, you see for this W, the length is going to be 4 meters. Now this will be adjacent for cos 45. So meaning that's going to be the perpendicular distance for cos 45. Now these are the only anti-clockwise. And using the principle of moment, it says the sum of anti-clockwise moments are equal to the sum of clockwise moments. Now, clockwise we have first of all RA. So RA times what's the perpendicular distance? You see RA is horizontal, meaning its perpendicular distance is going to be vertical. But now, you see, this is the distance we want, vertical to 8. So meaning from here up to here is the same as from here up to here. So meaning I need this, but this is a big triangle. So now if I'm to draw a simple triangle in relation to that, this will be still 45. Now, the length from here up to here is the length of the ladder, which is 10 meters. So this one is going to be, now this is adjacent, so adjacent will be 10 cos 45. Then this is opposite goes with the sine, so 10 sine 45. So meaning, from here up to here is 10 sine 45. So meaning, the perpendicular distance from here up to, you see the perpendicular from here up to here, is going to be the perpendicular from here up to here. So from this point, this force is going to be from here up to here. That's why I'm going to multiply with 10 sine 45. Then plus, there's also this force, which is 2 over 5 RA times, what's the perpendicular distance? Now, this one is vertical. Its perpendicular distance has to be horizontal. So from here up to here, it's going to be 10 cos 45, as simple as that. So the easiest way is that cos 45 is going to be 1 over root 2. Even sine 45 is going to be 1 over root 2. Or you can see, you can divide it through, because they are the same. This is equal to this. You can divide it through by, or we simplify. So this is y over 2 w times 1 over root 2 plus 4 w times 1 over root 2 equaling 2. My RA is here, 5 over 8 w times 10 times 1 over root 2. RA is this 10, and then this. Then plus 2 over 5. 2 over 5 times RA, which is 5 over 8. W, this is here, then this RA is there. Then times 10 times 1 over root 2. Okay, what is common? W is common. Divide through by W is common without. Another thing that is common is this. Divide through by this, by this, by this, then by that. What? Okay, let us see what we have now. We have y over 2 plus, here we have 4, okay, equaling 2. Here we have 50 over 8, this times this. Then here, this one is going to go first of all. We shall be having here, we shall be having this times this. We have plus 20 the whole over 8. Okay, so we can decide to get our y over 2 to be equaling 2. This will be giving us 70 over 8, then minus 4. So our y is going to be 2 when you cross multiply. You have 70 minus 32 the whole over 8. So imply that my y is going to be, can you simplify that? Okay, we are going to be having 70 minus 32 divided by 8 times 2, which is going to give us 9.5 meters. So it means that this man had ascended 9.5 meters before the ladder. He has to ascend 9.5 meters before the ladder slips. So if he goes beyond, the ladder is going to bring him down. So that's it, members. I wish you well.